Hello, in this video, I'm going to show you how to find the probability, the population mean, the population standard deviation, and population variance on a hypergeometric probability distribution, given a formula on a sharp EL-501X. The probability, as I mentioned right there, is not going to be fun, but it's possible. It's just you have to do everything by hand. This calculator does not have combinations on it or permutations, so it all has to be done by hand, and we'll explain how to do that right now. So an example for a hypergeometric probability distribution would be this. A bowl contains 10 white and 16 black beans. If I reach in and grab 7 beans without replacement, now when I say the words without replacement, it means it's basically a hypergeometric. So probability distribution, so I need those words. Find a probability that exactly 4 beans are white. So here I have a total of 26 beans, 10 of which are white and 16 are black. I grab 7 beans, of those 7 beans, I want the probability that exactly 4 of those will be white and 3 of them will be black. So because the whites are just white beans, they're not marked in any distinguishing way. It's a combination because the order doesn't matter. So you're just going to be picking 4 of the white beans out of the 10 choose 4. You'll be picking 3 of the black beans out of the 16 choose 3. Over the total number of ways to pick 7 beans out of 26. So 26 choose 7. So it would be written this way. 10 choose 4 times 16 choose 3 over 26 choose 7. So this is a combination. Combinations have been written this way historically for quite some time. And now with calculators, it's also could be written this way. 10C4, and this has gained prevalence over the years. 10C4 times 16C3 over 26C7. So since the calculator does not have this, all it has is something called a factorial key. What a factorial key is numbers that are the next number down. For instance, if I had 3 factorial, that'd be 3 times 2 times 1, or 6. 4 factorial, 4 with a little exclamation mark, would be 4 times 3 times 2 times 1, so on and so forth. So here, let me just talk about this for a second. NCR, so like I wrote it this way, can also be written NCR. N choose R, NCR, is n factorial over n minus r factorial times r factorial. Let me pick that up a little bit. So 10 choose 4, this guy right here, it can also be written 10C4, is 10 factorial all over the quantity of 10 minus 4 factorial times 4 factorial. That would be 10 factorial times divided by 6 factorial times 4 factorial. We're going to need this is the way we're going to be doing our problem. 16 choose 3 is 16 factorial over the quantity of 16 minus 3 factorial times 3 factorial. So 16 factorial over 13 factorial times 3 factorial here. Now this last one is going to be 26 choose 7. 26 factorial over 26 minus 7 factorial times 7 factorial. 26 factorial times the quantity 19 factorial times 7 factorial. So it would be written this way, but the only thing is, because we're going to be doing division, you want to put these things in parentheses. You want to put the whole thing in parentheses. So I tried to overemphasize that by putting it in blue right here, and we'll talk about that in a minute. So I hope you had a chance to look at that. I'm going to pull this away right now. And so now, remember this was 10 factorial divided by 6 factorial times 4 factorial. So let me show this here right here. I'm going to take a look at it right here. We would turn off and on the calculator. That would be 10. To get a factorial, it's above the clear the entry, the CE button, CE. Above it is n factorial, so hit second factorial. So what that number is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You can do that by hand, but since it has a factorial, I'll just use it. Divided by the quantity, so I need in parentheses, 6 second factorial times 4 second factorial, close parentheses. Times, because we're going to be multiplying this times 16 choose 3, this guy, 16 second factorial divided by open parentheses, 13 second factorial times 3 second factorial, this e button, close parentheses. Now, remember it's division, but we start off with the open parentheses, and we're going to do this guy, 26 factorial, 26 second factorial, divided by another parentheses, 19 second factorial, oops, gosh, bless it, second, 19 factorial, second, it's supposed to hit second factorial, times 7 second factorial, close parentheses, equals 0.178777744. Woo! Now, you do not need to do this. If you have a calculator that has a combination, it's going to be a little simpler, but you can do it on here. So that's what I meant by not fun. Everything else is pretty straightforward. In fact, now that we've done that, we can do the hard stuff. I mean, the nicer stuff. So notice, 26 we're going to call M, 10 we will call W, 16 is B, and 7 is N. So these numbers are not universally accepted. These are numbers I'm particularly using, and these are numbers we're going to be using for population. For population, you use everything above this line. For probability, you have to go one step further. But for population, you just use these guys. Now, to find the population mean is n times W over M, 7 times 10 over 26. So we would do the turn off and on, 7 times 10 divided by 26 equals 2.69. All right. Now, the population variance. Okay, looks like I have that on here. Good. Population variance, sigma squared, is n times W over M, this guy, times B over M, times M minus N over M minus 1. So that would be 7 times 10 over 26. B would be 16 over 26. And 26 minus 7 over 26 minus 1. So clearing this a little bit, you had 70 over 26 times 16 over 26 times 19 over 25. So the way you would do that, you would just multiply these numbers together, divided by, put this in parentheses. So you want to put that in parentheses. Uh-oh, sorry. Okay, you'll see that. Good. So I'm going to clear this, and I'm going to go 70 times 16 times 19 divided by open parentheses 26. 26 times 26 is 26 squared, so I'll just hit x squared times 25, close parentheses, equals 1.259. Now, here's something that's kind of nice, right? The population standard deviation. I'm going to go ahead and pick this up a little bit. I can keep it. I can't keep those numbers up there, so hopefully you will remember those. So let's do this. Population standard deviation is the square root of variance. This is variance. Now to hit the population standard deviation, I just have to hit the square root button. 1.122, 128, et cetera, et cetera. That's all I have to do. However, there are some people listening right now that says, well, what if I don't want to find the variance first? Perfect. What we do is this, clear it, start with the parentheses, and do this step right here. 70 times 16 times 19 divided by open parentheses, 26 squared times 25, close parentheses, equals, or another parentheses or equals, and then hit square root, and you got it. So I notice right here I didn't hit equals, I hit the parentheses, so let me show you that way, okay? It would be open parentheses, 70 times 16 times 19, I know I'm running through it fast, divided by open parentheses, 26x squared times 25, close parentheses again, square root, and it gives it to you. So if you hit the equals here, that's great. You hit parentheses here, that's great too. Anyway, I hope you find this beneficial. Thank you so much for listening. I know it's a little difficult as far as the probability goes up there. That is pretty kind of difficult. I agree with that. But it's possible. I showed you it's possible. It just takes a little bit of time. I hope you have a blessed day. Thank you so much for listening, and I'll talk to you.